Okay, so let's look at this example here. So this is an application type example where we're looking at the trajectory of a rocket over time. So this is the height of the rocket over time with t as a unit of time. And in this case here, I think it's yeah, the time of flight. So it doesn't give the units, but it's time of flight. Now, if we wanted to factor this out, the very first thing that we want to do is factor out the greatest common factor. And so now we notice that this has a factor of 2, a common factor of 2. Now, there might be a greater, we want the greatest common factor, but sometimes you don't see it, right? It's obvious that this has a factor of 16, and so does this. But it's not sure that this has a factor of 16. Now, I could factor out 4, right? Because it does have a factor of 4, okay? So, let's factor out 4. And so we have 4t squared plus 60t minus 400. Now, notice that this is factorable by 4, so is this, and so is this. So it is actually factorable by 16. So this actually, if I factor out another 4, this 4 becomes 16. This becomes t squared. This becomes 15t, right? Minus 100. Okay, so again, sometimes you don't see what the greatest common factor is, but it's okay to do successive factoring. Just make sure that when you're done, you get something that has no common factors other than plus or minus 1. Now we're ready to factor. Now, look at this. We've got a leading coefficient of 1, so that means all we have to do is look at the constant term and find 2 factors that add up to 15. Well, this is negative, and that means they have to have different signs, and the larger factor has to be positive. So in this case here, what are 2 numbers that multiply to 100 but add to 15, positive 15? So let's see, that's going to be 5 and 20, right? So negative 5 and 20. And we're done. Okay. We'll see you next time.